Algebra 2, Target 7, I can operate within the complex number system. Today the focus, we're going to talk about multiplying and dividing with complex numbers. Now if you remember from yesterday's video when we talked about adding with complex numbers, what we did is we treated I like we had a variable. It's not a variable because it always means the same thing, but you can still use it like you would. Right? Same thing with multiplying and dividing. We're going to treat I like you would a variable. But knowing that it's a number, sometimes there's some things that happen that are a little bit different. So let's take a look at this. When you're multiplying, you're going to just multiply like you would if it was x. So take a look at A. If I were to multiply that, if that was x, I would distribute. All right? Well, so I'm going to treat it like it's a variable, and I'm going to multiply, distribute the 4i through. And I would get negative 24i plus 4i squared. Now, anytime you see I squared, you got to remember, okay, that's not a variable. All right? Remember, I means the square root of negative 1. So that means I squared, excuse me here, that means I squared is negative 1. So every time I see I squared after I multiply, I need to substitute negative 1 back in. So negative 24i plus 4i squared, that's really negative 24i plus 4 times negative 1. And that simplifies to negative 4. Now it says standard form, and in standard form, the real component comes first. So I'm going to put that negative 4 out front. So my final answer here is negative 4 minus 24i. All right, let's look at the second one. What would we do if that was x? Well, we'd FOIL it, or we'd use the box, whichever method you use. So I'm going to do that. I'm going to use the box. All right, it's going to be 9 minus 2i and negative 4 plus 7i. And I'll fill in my box. Negative 4 and 9 is negative 36. Negative 4 and negative 2i, that's 8i. 7i and 9 is 63i. And then negative 2i and 7i is negative 14i squared. All right, now as we combine like terms, we need to remember that I is not a variable. I is the square root of negative 1. So I squared then is negative 1. So as we combine like terms, these two will combine, 63i plus 8i. These two will combine because I squared is negative 1. That's going to be negative 36. Negative 14 times negative 1 is plus 14. And combine like terms, remembering to put the real component first. Negative 36 plus 14 is negative 22 plus 71i. So there's our number in standard form. It's the same thing that we've been doing with FOILing through with x. The only difference now is when we have I squared, we're substituting negative 1 in for it. All right? And that brings us to division. When we divide by complex numbers. All right? When we divide by complex numbers, to get into standard form, we need to do a little manipulation. We use something called a conjugate. Now, a conjugate should make you think of difference of squares. If you can remember back to doing difference of squares. An example of difference of squares, x minus 4, x plus 4, that's a difference of squares because when you multiply it out, it's a subtraction of two squares. Right? And these are called conjugates because one's adding, one's subtracting. And when we multiply it, if we did our box, we'd have negative 4x and positive 4x, and those would cancel. They're called conjugates because of that canceling. It's a special multiplication. Well, for complex numbers, same thing. If you have 2 plus 4i and 2 minus 4i, those are conjugates because if we were to FOIL it, we'd do our box. 2 times 2 is 4. 2 times negative 4i is negative 8i. 4 times or 4i times 2 is 8i. These are opposites, so they cancel. And then negative 4i and 4i is 16, or negative 16i squared. I squared is negative 1, so that ends up being 16. So really we end up simplifying to 20. So we took here two complex numbers and multiplied them, and we got a real number, right? And then this is important because it allows us to write the division of complex numbers in standard form. So if we take a look, we can use complex conjugates for dividing complex numbers by multiplying both numerator and denominator, creating a real number in the denominator. All right, so let's look at what we mean here. So here we have an example. Write the quotient in standard form. 7 plus 5i divided by 1 minus 4i. So let's take a look at this. We want to get it so that there's just a number in the denominator. And I can change the denominator by multiplying by the conjugate. However, that changes the problem. If I multiply part of the problem by something, I've changed it. So I need to keep balance, and that's where I multiply the top also by 1 plus 4i. Really, what I've multiplied by is 1, because I've multiplied the top and bottom by the same thing. Now, as I work through this, this is a complex conjugate. It's like a difference of squares. It's really going to be the first term squared minus the second term squared. The top, we will box it. So we got 7 plus 5i, 1 plus 4i. Fill in the box. We got 7 here, 5i here, 28i there, and 20i squared here. As we kind of clean this up, we got 7 plus 28 and 5 is 33i plus 20i squared. Now remember, I is not a variable. It means something. It means the square root of negative 1. So that means I squared means negative 1. So as we fix this up, we got this is negative 20, because I squared is negative 1. 7 minus 20 is negative 13 plus 33i. And on the bottom, this is positive 16, so we got 1 plus 16 over 17. And we can make this into standard form by splitting that into two fractions with 17 as our denominator. So all your complex numbers should be written in standard form, real plus imaginary. So in review, when multiplying with complex numbers, you do it exactly the same way as you would when multiplying with x. The only difference is when you're done, anytime you see I squared, replace it with negative 1.